All right, this is the second video and we are going to continue our discussion of homework number 5. But instead of looking at a specific problem, in this video we are going to look at a problem which is very similar to the one that we just solved in the first part of the video. Here the only difference is that instead of looking at R4, we are working in the vector space M2 by 2, which consists of all the 2 by 2 matrices. Same as before, suppose that we are given a 4 fixed matrices. So instead of V1, V2, V3, and V4, we have A1, A2, A3, and A4. These are all the 2 by 2 matrices. And let us consider the span of all these matrices, which is a span of A1, A2, A3, and A4. Which is defined as a set of the elements that looks like this, where C1, C2, C3, C4 are real numbers. That is to say that the span of A1, A2, A3, A4 consists of all the linear combinations of all these matrices. Now, before that, when we have V1, V2, V3, and V4, we see that the span of V1, V2, V3, and V4 is exactly the entire R4. So now the question is that whether or not in our case, will we also have that the span of these 4 matrices equals to the set of all the 2 by 2 matrices. Okay, that is to say that whether or not all the 2 by 2 matrices can be written as a linear combination of A1, A2, A3, and A4. Now, so to do this, we'll have to consider taking an arbitrary elements from this set and call it A with entries A, B, C, and D. Now, we are not making any special assumptions on this A, B, C, and D because we want to see whether or not any matrices in this set can be written as a linear combination of A1 to A4. So if you make any assumptions, then we are no longer looking at a general case, we will be looking at a specific case, and that will not work. So the question now is that whether or not given this matrix A with entries A, B, C, and D, can we find the numbers C1, C2, C3, and C4 such that the combination here gives you the matrix A with entries A, B, C, and D. Now, if you can find the value C1, C2, C3, and C4 such that this equals to that, then we know that this matrix will be in the span of all these 4 matrices. Okay? Now, so let us look at the what happens if you write out that equations. So you have these equations here. So writing out A1, A2, A3, and A4 to be these 4 specific matrices, we will obtain the following system. Okay, with following equations, and we know how to multiply scalar with matrix and also how do we add them. So we do it, for example, let's look at the first component here. You will have C1 plus C2 plus C3 plus C4. It has to be equals to A. And the second component here will have a 0, and then C2, and then C3, and then C4. The sum will have to be B, so on and so forth. All right. So the equality of this matrix, the equality of these 2 matrices will give us the system of 4 equations because C1, C2, C3, C4, the sum of it will have to be equals to A, this will have to be equal to B, this will have to be equal to C, and this will have to be equal to D. All right. So once we have this system, it is actually very clear that this system is consistent. No matter what are your A, B, C, and D, we can always find solutions C4, C3, C2, and C1. We don't really have to row reduce it to REF form. Just by this, we can tell that C4 has to be D. And then back substitute, you will have C3. And then back substitute using information C4 and C3, you will find C2. And then back substitute one more time, you will have C1. And you can see that obviously the C1, C2, C3, and C4 will have to be connected with the A, B, C, and D of that matrix. So the system is actually consistent. Okay. Therefore, we see that no matter what are the entries in this A, B, C, D for this matrix A, we can always find these 4 numbers C1 to all the way to C4 such that the matrix A can be written as a linear combination of all these 4 matrices. Okay, now following argument like this, you can and you should be able to answer problem 2, 3, and 4 in your homework 5. And problem 5 are the same, it's just that instead of working in R4 and the spaces of 2 by 2 matrices, we are working on the polynomial of degree at most 2. So we are changing the vector space. So you have to be comfortable with originally starting at like a very typical R4 or like Rn vector space, and then started to transition and move it to slightly more abstract vector spaces, like the space of all the polynomial of degree at most n, or like the space of matrices of size n by m, so on and so forth. All right, so the things are that all these computations are the same, it's conceptually the same, just that we are working in a different vector space. And you must be very comfortable with this transition from Rn's to abstract vector spaces, because these are the bread and butter of this course, okay?